गुड मॉर्निंग फ्रेंड्स। तो करते हैं शुरुआत। आज का जो हमारा टॉपिक है वो है एन्यूप्लॉयडी, एन्यूप्लॉइड्स, राइट। सो मूव अवर टॉपिक एन्यूप्लॉयडी, एन्यूप्लॉइड्स। अमोंग द एन्यूप्लॉइड्स, मोनोप्लॉइड्स, पॉलीप्लॉइड्स स्पीसीज, टोबैको, वीट, ओट एंड Rhizomic diploid species datura, maize, bajra, tomato, rye, pea, and spinach are the most commonly used genetic studies. Rhizomic are divided into three parts, right? So first of all, what is aneuploidy? I told you aneuploidy. Among the aneuploidy, monoploids, uh, polyploid species, tobacco, wheat, and trisomic diploid species Dhatura, maize, bajra, tomato, rye, pea, spinach are the most commonly used for genetic study. First is primary trisomic. First is primary trisomic. Primary trisomic, the extra chromosome is the same one of the haploid genome. Primary trisomic is the extra chromosome. The extra chromosome is the extra chromosome is same as one of the haploid genome. This is called primary genome, primary trisomic. Next is secondary trisomic. Secondary trisomic, the additional chromosome in an isochromosome, right? Third is tertiary trisomic. Tertiary trisomic, extra chromosome in translocated one. Okay. So now we are discussing about origin and production. Origin and production. First, spontaneously autotriploid plants, asynaptic and desynaptic plants, tetralocation heterozygote, tetrazomic plants, morphological and cytological feature. Morphological and cytological feature are aneuploids are generally weaker than diploid. जो aneuploid होते हैं वो weak होते हैं comparison than diploid. Monozomic do not survive in diploid species. Monozomic can't survive with in diploid species. Neulozomic do not even in polyploid species. Tobacco, right? Next is trisomic only survive in diploid species. Trisomic survive only diploid species, maize, barley, pea, tomato, kombu, right? Next is tetrasomic, less regular. Tetrasomic is less regular. Okay. Next question. Next heading is application in crop improvement. What is the application of aneuploidy in crop improvement? Aneuploids are useful in locating a linkage group and a gene in a chromosome. Aneuploids are useful in locating a linkage group and a gene in chromosome. Next is useful in the studies on effect of loss or gain of an entire chromosome. Useful to study the homologous between the genome. Useful in identifying modifying the chromosome involved in translocations, right? Useful in the production of substitution lines. Next, we will talk about autopolyploid T. Autopolyploids which originate by multiplication of the chromosome of a single species, right? Next is origin of and production. Origin and production. Autopolyploidy spontaneously produce treatment with physical agent, cold, cold treatment, heat treatment, cold treatment, heat, X-ray, gamma rays, heat treatment successfully in wheat, barley, rye, right? Chromosome doubling. Chromosome doubling. Colchicine is isolate from seed 0.2 to 0.8% and bulbous 0.1 to 0.5% of colchicum automains. Colchicine treatment prevent spindle formation and inhibit the movement of sister chromatid. Other chemicals, acenophane, 8-hydroxyquine and nitrous oxide. Next, we will talk about morphological feature. Morphological features are three. Polyploidy have first is polyploidy have large size than diploid. Polyploidy have large size in diploid, right? Next is pollen grain are larger. Pollen grain are larger. Third is to increase general vigor and vegetative growth. Next is cytological feature. Cytological feature is autotriploid. Autotriploid highly sterile. Autotriploid highly sterile. Watermelon, banana, and highly fertile spinach, right? Autotetraploid fertile can be improved through selection maize, kombu, rye, rice. Next is role of autopolyploids in crop improvement. Role of autopolyploid in crop improvement. First is triploids, banana, seedless, large fruit, seedless watermelon commercially grown in Japan, not in our country. Seedless watermelon commercially grown in Japan and also another country, but in our country uh, at this time it is not growing. Maybe in future it will be happen. Next is triploid sugar beet, large root and more sugar per unit area, grown in Europe. Next, triploid tea cultivar. Triploid tea cultivar TB29 produce large shoot and more biomass, commercially cultivated in India. Autopolyploid are Autopolyploids are large in size and are more vigorous than diploid forays. Crop are successful, red color and ryegrass like clover and berseem. Autopolyploidy are large in size. Autopolyploidy large in size are more vigorous than diploid. Forage crop are successful. Autopolyploidy forest crop is more successful. Uh, Red clover, ryegrass, alike clover, and persimmon. Pusa gained persimmon in the first Aneuploid variety released for general cultivation. India yield 20 to 30% more green fodder, more green fodder yield persimmon variety HTM 1 Hyposiomus niger in autopolyploid, uh, 15% more biomass, 36 greater crude drug than diploid parent. Okay. Sugandha is a autotetraploid variety, uh, give 11% more oil yield than the control. Rye tetraploid variety double steel tetra petuk have been released for cultivation. So now we can see here autotetraploid 4x, some autopolyploid species, autotetraploid 3x, autohexaploid 6x, right? Autotetraploid 4x, autotriploid 3x, autohexaploid is 6x. Autotriploid crop is autotetraploid crop is potato, groundnut, coffee, lucerne, persimmon is also right. Next is autotriploid banana, sugar beet, spinach, watermelon, or tea. Autohexaploid sugar beet, sweet potato is autohexaploid, right? Coffee, lucerne, these all autotetraploid. Potato, groundnut, coffee, lucerne, persimmon is autotetraploid. Okay. Holopolyploid, D, a polyploid organism which originate by combining chromosome set from two or more species, right? Holopolyploidy, a ploidy organism which originate by combining chromosome set from two or more species. Origin: chromosome schedule, irregular mitotic cell division. Chromosome doubling, chromosome doubling, irregular mitotic cell division of F1 hybrid. Irregular meiosis, irregular meiosis lead to production of unreduced gametes which may be unit to holopolyploidy, right? Brassica oleracea, Ramphus sativa, Ramphus Raphanobreska sterile colchicine treatment, chromosome doubling. These are holopolyploid. Next, synthetic holopolyploids, two-step production of F1 hybrid. Synthetic holopolyploid, two-step production of F1 hybrid, chromosome doubling, colchicine treatment. in critical, right? Next is role of oligopolyploidy in crop evolution. Oligopolyploidy have been more successful as crop species than oligopolyploid. On third of angiosperm are polyploidy and majority are oligopolyploids. Evolution of bread with Titcum aestivum. See here oligopolyploidy used in Titcum aestivum. Titcum bred with Titcum monococcum have N7AA, right? And A speltoids N7BB, right? When here is cross F1 fertile AB. Spontaneous chromosome doubling. Here spontaneous chromosome doubling AA, capital A, capital A, capital B, capital B, right? A squarosa dicoquoids N7DD tetraploid emer wheat turmeric tetraploid tergidum variety N equal to 14 AAVB, right? Here is A and B and D. Spontaneously chromosome doubling AABBDD hexaploid wheat N equal to 26, 21 N equal to 21 amphidiploid, right? Evolution of Nicotiana tabacum N equal to 24 N slavis N tomentosa N equal to 12 N equal to 12. Spontaneously chromosome doubling and tabacum N equal to 24, right? So evolution of Gopicium hirsutum, Gopicium herbaceum variety Africum 2N equal to 26, Gopicium Ramondi 2N equal to 26, chromosome doubling Gopicium hirsutum. F1 is Gopicium hirsutum. So that's all for today. So I hope you understand this video and I give my 100% to explain this video, explain this thing. So thank you for watching and we will continue after complete genetics and plant breeding. We will discuss about multiple questions and one-liner questions is also. So thank you very much.